Assalamualaikum and greetings. I am Kami Khalili bin Haji Allah. I'm A18217 from Group 6. And today we are going to present the Lab 1 experiment, which is the Bernoulli principle.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Amirul Ikmal bin Muhammad Zulmi. My ID number is MA1A1. So today I want to present about the experiment 1, that's a Bernoulli theorem. So for the abstract is, for the experiment 1, we're going to do the experiment to prove the Bernoulli theorem. Firstly, we need to design and construct a complete measurement technique for fluid flow and verify the Bernoulli theorem experimentally. Formula of Bernoulli was used to calculate the sample calculation that's shown in the result. The graph have been plotted such as graph of static, dynamic and total heat against flow rate and position for the data obtained at the result. Lastly, we need to verify that does it follow that Bernoulli theorem as the experiment stated. So I think that's all from me. Thank you.
In this experiment, we are investigating the variation of pressure head, static head, and dynamic head. The total pressure measured by a pitot tube, while the static head is measured through the multi-tube manometer. The venturi apparatus is then used to vary the static head and dynamic head. The static head are measured at all 6 points of venturi at any flow rate. The flow rate can be measured through the volumetric tank, and lastly, the fluid velocity at all 6 points of the venturi can be calculated through either the volumetric tank or the dynamic head. Bernoulli's principle states that a flowing fluid at velocity will create a low pressure area. This phenomenon is called the Bernoulli effect. The effect is explained through this equation: P over rho g plus v squared over 2g plus z equals to constant. This equation takes account the relationship between elevation, fluid density, velocity, and pressure. It is only valid for incompressible flow in a region of steady state. The net frictional force also needs to be negligible. The static head does not incorporate any dynamic effect. It represents the actual thermodynamic pressure of the fluid. Next, the dynamic head represents the pressure rise of the fluid while in motion is brought to stop entropically. The elevation takes account for the reference level selected, that which includes the effect of fluid weight on pressure. Bernoulli principle is a mathematical method to understand the mechanics of fluids. By understanding the mechanics of fluid, we could use it in the real world. This can be seen through the aerodynamics of aeroplane, calculating wind load on a plane, designing a water supply pipeline, and sewer system. Although the equation is simple, the principle involved plays a vital role in advanced designs to improve human life.
Hello, my name is Stephen Wang Tek Ching, and I will present about the objective. The objective in our experiment is to investigate the validity of the Bernoulli equation when it is applied to a steady flow of water through the tapered duct. The second objective is to investigate the variation of total pressure head, static head, and dynamic head. The scope of our experiment is to investigate the variation of total pressure head, static head, and dynamic head. The measurement of the static head and total head will be taken at 6 points in the venturi. And due to the Bernoulli principle, the flow inside the venturi will be assumed of steady flow, and the flow frictions will be negligible.
Assalamualaikum and a very good day. I am Nur Azira binti Herman Toching Ho, MA18232, represent about the theory of Bernoulli principle. The Bernoulli principle was founded by Daniel Bernoulli in the 1738. Bernoulli principle is a condition when the flow velocity increase, it will decrease the pressure produced by the fluid. This happen on vice versa condition too, which is when flow velocity decrease, it will increase the pressure produced by the fluid. One example for this principle can be seen through the flight of aeroplane, which when the airflow on the top of the wing move faster, thus it will create low pressure condition, and the below part of the wing has lower velocity, thus create high pressure condition. The differential pressure will lift the aeroplane. Now let's look on the Bernoulli equation used in Bernoulli principle. To use the equation, the fluid must have the condition of steady, incompressible, and inviscid region flow. Bernoulli equation consists of three quantities, which the first one is pressure head, or known as static head. That the equation is pressure over density times gravity. Second equation is velocity head, or known as dynamic head, which the formula is flow velocity to the power of 2 over 2 times gravity. The third equation is z, that indicate the elevation head. The inversely condition between flow velocity and pressure will have two constants of total magnitude of static pressure and kinetic pressure. Thus, Bernoulli equation will be as shown on the slide. Another point about Bernoulli equation is that it uses approximation in derivation. This is because most fluid flow is steady, net frictional forces can be neglected, and small value on compressibility effects. As shown at the slide, Bernoulli equation only valid in the region outside of boundary layer and weights. That is why the equation only applicable on steady flow. Another form of Bernoulli equation is the previous equation times with gravity, in which it will be the form of flow energy equation, which is pressure divided by density, plus with kinetic energy, which is velocity flow to the power of 2 divided with 2 and plus with potential energy equation, which is z, elevation head, times gravity, equal to constant. The Bernoulli equation is derived from Newton's second law for fluid moving along straight line and first law of thermodynamics applied to steady flow system, and this equation is commonly used to solve fluid problem. That is all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Amir Muhammad Azmi. My ID number is MA181. So today I want to present about method and procedure. Okay, for the first one, for the method procedure is to construct complete measurement technique for fluid flow. Next is to verify Bernoulli theorem experimentally for viscous and incompressible fluid. Okay, as we see list of material, list of equipment. Okay, we go next to the experiment procedure. Okay, for the firstly, the pipe with manometer with and water flow control with are ensured to fully open and pipe with 2 to half open. For the next procedure is the motor pump was started so that the water are overflowing in the manometer valve and single pitot manometer valve in order to expel any air bubble from both manometer by the speed of water flowing by controlling the water flow wave. For the third procedure is the manometer wave and single pitot manometer wave were closed. The next is the pump was stopped and pipe valve 2 was closed simultaneously while pipe valve 1 is remain fully open. Next is a manometer valve and single pitot manometer wave were opened carefully to allow the atmospheric air to get into it. Next is both manometer and single pitot manometer wave were closed when reached about half of the column. Next is single pitot manometer and manometer wave were reopened. The next is pipe wave 2 was fully open and water flow control waves was adjusted so that the position of all water level in the manometer were reliable starting from tube B1 until tube B6. Next is all seat position of pitot head and static head in the virtual tube were recorded by adjusting the pitot tube. And the next is on. So for the precaution, the first is the parallel error should be avoided while taking reading. The next is maintain a constant discharge for each reading. The next is note the mean position carefully as there may be a fluctuation in the reading when fluids flowing. And last one is ensure there is no air bubbles in the manometers and when you read it. So I think that's all from me. Thank you.
Assalamualaikum. My name is Nuri Antira binti Mak Yamin, MA18260. Today, I would like to tell about the result and the graph. In this part is about to discuss the result and experiment and the graph. Okay, next, The table below shows of measure the dynamic head, velocity and total head. So we can calculate dynamic head, velocity, total head and pressure dynamic for the measure. Okay, for the next table, after we got the value of measure, we calculate the area, the flow and the velocity. Okay, for this table show that after measure, we calculate new value of calculated dynamic head, velocity, total head and pressure. Okay, next, this part will show the graph that we plot using Excel. So we can see the graph of measure and calculated velocity head and dynamic head, and the graph almost same design. Measure velocity is increasing and decreasing at point 2 and increase slightly at point 3. Calculate dynamic head at point 4 to see it is rising sharply compared with measure dynamic head which is decreasing. Okay, next, for the total head graph, the highest value is at point 6 for measure and the lowest is point 3 for calculate. Okay, next, graph pressure versus point venture, it shows that the area of the flow velocity is increased and the pressure increased too. At point 4 to see it is rising sharply compared with measure pressure which is decreasing. That's all from me. Thank you.
I will continue with the discussions. From the graph, the value of the calculation is different with the measure in the experiment. It shows that the error of this experiment is very high. This is because the pipe's inner surface cannot be considered absolutely frictionless. When the fluid flows through the pipe, it will produce the friction between fluid and the tube. This will cause the velocity and the pressure will decrease when it flows through point 5, 4, and point 6. This phenomenon can be explained with the direct equations. It is 1 over 2 rho v square CD A. And to reduce the friction error in this experiment, we can reduce the length of the tube from the inlet. This will make the error decrease, and the result of this experiment more accurate. For the conclusions, in these experiments, with the measurement of static head, the relationship between the static head and the dynamic head is existing according to the Bernoulli equations. That's all from us. Thank you.